It's time for your favorite math time adventures.
Hey kids! Welcome to Math Time Adventures! It's time for some math time. Alright, so today's problem has to do with cars. Vroom vroom! Am I right, Dr. Alex?
You're right, Dr. Lee.
That's true. My name is Dr. Lee. Alright, hand me the pen.
Marker.
Marker. So, here's the problem. Cars on a certain roadway.
Cars on a certain roadway travel at velocity v on a circular arc of radius r. In order not to rely on friction alone to overcome the centrifugal force, the road is banked from the horizontal at an angle of theta, as can be seen in this diagram. The angle of banking can be determined by the equation rg tan theta equals v squared, where r is the circular radius of the road, g is the gravitational constant 32 feet per second squared, theta is the angle, and v is the velocity of the car. But why does the road need to be tilted? Let's ask Dr. Lee.
Hey kids, Dr. Eli here. The road needs to be slanted so the car doesn't go flying. Up, up, and away! Hey! So what we have to do is find the relationship between the derivative of v, velocity, and the derivative of theta, the angle of the roadway. Time to do the math.
Marker, please?
I think I'll take care of this, Dr. Alex.
No, Dr. Lee.
No! No!
Oh!
Alright, Dr. Alex, you can do the math.
Okay, this is the equation that gives us the relationship between velocity and theta. To find that out, we actually have to get the derivative. And to do that, we have to find the derivative of both sides. These two remain constant, g being 32 actually, because it's the acceleration due to gravity, it's actually 32 feet per second. R is the radius, that remains constant, or else we would never need theta. And so we have to translate that into its derivative form, which is secant squared theta, and then add the d theta over dt equals the derivative of this, which is dv over dt to... Now we gotta simplify. So keeping 32r, we have to get all this stuff over to this side. So that means that this is actually dv over dt 2v over 32r secant squared theta equals d theta over dt. Now then, we can also simplify it further. Getting rid of this, which will be 16. Secant squared is actually 1 over cosine squared theta. So that could actually switch over to cosine squared theta up here. Getting rid of that. And so the final answer would be r dv.
That's a v.
No, r, sorry, that's a v, sorry. dt cosine squared theta over 16r equals d theta over dt.
Wait a minute, Dr. Alex. Looks like you forgot something. You didn't write the closed parentheses.
Looks like we're going in circles. Whoa!